All right, so here's a multivariable limit. So in this problem, we're looking at a limit as x, y approaches 0, 0 of this particular function. So now if you try to substitute 0 immediately, you'll see that you'll get 0 over 0. So that's not a wise thing we can do here. So we need to find another way to evaluate this limit or show that it doesn't exist. So it seems like the limit does not exist, but let's see if we can show that. So we're going to use the two-path test for a limit to show that if you take the limit along one path and then take the limit along another path, you get two different values. That means the limit does not exist. So we're going to choose two paths. So let's say, let's take a look at along the path y equals 0. So we're going to look at along the path y equals 0 because this line will pass through the point 0, 0, so it's a good path that we can test. So that means we're converting this to a single variable limit. So we have the limit now as x approaches 0, since we're substituting y equal to 0. So we're going to plug in 0 here and 0 here, so it reduces to a single variable limit problem. So we're going to get x squared cosine of x over x squared because y is 0. So this will simplify. So we have the limit as x approaches 0. Now we can here simplify these guys right here. That will give us just cosine of x. And if you substitute 0 into this function cosine of x, you're going to get cosine of 0. And we know cosine of 0 is 1. All right, so along this path, our limit is 1. Now let's test another limit, and we hope that we get a different value. Let's take a look at along. Now, again, you're going to choose the path so that it goes through this point. So for example, if I choose now, let's say y equals x. So that line also passes through the point 0, 0. So y equals x is also a nice path that we can approach along. So then we have the limit. Again, it becomes single variable limit as x approaches 0. Now we're going to replace y with x. So here you're going to replace x, here you're going to replace x. So you'll have the limit of x squared cosine of x plus x all over x squared plus x squared. Again, we're approaching along y equals x, so replacing y with x, and we have this limit to evaluate now. So this is equal to the limit as x approaches 0. So we got x squared cosine of 2x over 2x squared. Now again, we can simplify this and this can cancel. So this will give us the limit as x approaches 0 of cosine of 2x over 2. And now if you substitute 0, we have cosine of 0 over 2, which will give us 1/2. All right, so mission success. We have limit value to be different. So along this path, y equals 0, our limit is 1. And then along different path to y equals x, our limit is 1/2. Now, since both limits are different, and by the two-path test, we can say that the limit of the original xy approaching 0, 0 of x squared cosine of x plus y over x squared plus y squared does not exist.